Hello. Last time we talked about temperature and what temperature is, which is the measurement of the energy that is transferred between objects. Okay. So we talked about heat. We talked about how we measure heat, which is using a thermometer. So today we're going to talk about what exactly is heat. So heat is the energy transferred between objects because of their differences in temperature. We talked about last time how if you have a warm object and a cool object, the heat will go from the warm to the cold, whatever the material is. And we measure that transfer as temperature. Well, heat is the actual what is being transferred. It's the energy transferred. Okay. The warmer side or the hot side has a high kinetic energy. The cool side has a low kinetic energy. The warm side has high internal energy, and the cool side has lower internal energy. Okay. These are all things we covered last time. So energy is being transferred because these particles have more energy than this side. And so this energy is being transferred through collisions. Heat is not the same thing as temperature. Temperature is the measure of the internal energy, where heat is the transfer of energy. Okay, heat and energy are both measured in joules. If you think about the previous chapters, energy is always expressed in joules here in physics. Around the world, other units have been used are calories. We all know what calories are. Kilocalories, British thermal units, then there's the dietary calorie, and the therm. But here in class, we will use joules. And this is another slide just expressing different areas, uses in which they use the different scales, or the different units, I should say. Okay, heat and work. Work is the transfer of kinetic energy. Think back to the energy and work unit we covered. Work is the transfer of kinetic energy. Heat is the transfer of internal energy. Internal meaning the energy of the particles. Friction is one way to increase the internal energy. Okay, we all know what friction is. It's the reason your hands warm up when you rub them. Total energy is still conserved. Okay. Think back to the conservation of energy, the conservation of the potential energy and the kinetic energy. Plus, we said there was a heat component. Think back. Well, now we're going to talk about that heat component. So if they're conserved, that means in a system, all of the kinetic, the potential, and the internal energy, we don't lose them. They get transferred from one form to another, but we don't lose them. So if you were to add them all together, the changes of, you'll get zero, meaning we don't lose it. So the change of kinetic energy, the delta potential energy, is the same as work, and AU is the same as heat. There's our correlation. So how is this energy transferred? Okay, it just doesn't magically happen. There's different methods. The first one is thermal conduction, the process in which energy is transferred as heat through the material between 2 points at different temperature. This is the one we talked about, going from warm to cold. Okay, because they're in contact with each other. Thermal conductors transfer energy as heat easily. Most metals are conductors. Okay. The opposite of that would be an insulator. Okay. Just the opposite. Insulators are what we use to keep the energy from being transferred. So it slows down the transfer. These would things be like asbestos, cork, ceramic, glass, cardboard, gases. Air is a great conductor because heat does not transfer through air as easily as it can other materials. Fiberglass, plastic. This would be like your fiberglass insulation in your homes. Okay. We use it because they are not good conductors. Therefore, we use them as insulators. Cooking oil. We all like fried food. So cooking oil is not a good conductor. It's actually a insulator, but we use it because it transfers the heat evenly around the food. So you get a nice even cooking of your French fries. Okay, another method that heat is transferred is convection. This is when warm air, warm liquids like water, whatever system you're looking at, warm rises, okay, because it's less dense. Particles are further apart because it's warm and they have more energy. They rise, and the cool air, water, whatever, comes in behind them and replaces them. And then as this warm material starts to cool off, it will get more dense and it will start to sink. Meanwhile, the cool materials that were there, will start rising again. So you get these convection currents going up, cooling off, sinking down, getting rewarmed, rising up. This happens in our atmosphere, it happens in our oceans, and it happens in the mantle of the earth. Okay? They all have some kind of material that is rising and falling due to their changes in temperature. The next kind is one that you're probably more familiar with. Think of the sun, a campfire, your fireplace in your home this winter. So radiation, the energy is transferred as waves. The matter doesn't actually go, but it's waves. Okay. And like I said, the sun, microwave oven, the energy is transferred in waves, and the actual matter, meaning the air matter, is not moving, but the energy is passing through it. Okay, next slide. Clothing and climate. Okay, this last cold snap we had, why do we wear multiple layers of clothing when it's cold outside? Why not just wear one big heavy something? Well, it's because air is not a good conductor of heat. It's an insulator. So by wearing multiple layers, if you can trap layers of air in your clothing, that the air works as an insulator. It keeps your heat of your body, the energy of the heat in your body, from being lost to the atmosphere. Same difference with hot weather. Here in Texas, it gets really hot. So you cool the body off in hot weather because that you trap cool air close to your body, or you trap the evaporate sweat to cool the body. So you're evaporating from the clothing, your body absorbs the sweat, it evaporates, or you're trapping cooler air than your body close to your body, and it works as an insulator and it cools you off. So that's the end of the slideshow. Please get your notes written, Avid format, in your journal. Take a picture of them, send them to me in Schoology. Thanks, guys.